So we have finished with the pin diagrams of 885 microprocessor. We'll revise all pins in brief again, but first we'll finish this functional block diagram of 8085 microprocessor. Now you can say this is a diagram where you can connect all the things which you have done till now. अभी तक आपने जो भी पढ़ा है जितने भी टॉपिक्स पढ़े now you are merging all topic and you can make a functional block diagram. So this is 4 mark question. It is there in your board exam. It is we have one more this type of diagram that is called functional block diagram of generic microprocessor. Generic means general purpose microprocessor. So in this, if you can see, it is means before 8085 microprocessor. So in this, it had only 2 register HL. 8085 may you have 6 register PC, DV, HL. In this, you have only 2 interrupts, I think. Only 1 interrupt INTR. Now you have 5 interrupts.
Ma'am,
Yes.
will you have to draw this in the exam or?
Yes, you have to buy her this diagram. It is compulsory. ये बहुत 3-4 इसके diagrams हैं. That is a block diagram of microcomputer, basic block diagram of microprocessor. This is functional block diagram of microprocessor. तो ये लेबल डायग्राम आता है, एक्सप्लेनेशन नहीं आता है इसका, सिर्फ डायग्राम यू नीड टू ड्रॉ इन 4 marks. And प्रोग्रामिंग मॉडल मीन्स रजिस्टर ऑर्गेनाइजेशन का डायग्राम आता है, पिन डायग्राम रहता है, एंड फ्लैग रजिस्टर का डायग्राम और उसके बेस पे प्रॉब्लम, और जो इंस्ट्रक्शन साइकिल मशीन साइकिल के साथ जो डायग्राम है, डीमल्टीप्लेक्सिंग का डायग्राम, तो वो कुछ 5 to 6 डायग्राम्स इट इज देयर. और ये जो है मेन बड़े 2 डायग्राम है. तो मैं वही बता रही थी आपको कि यू नीड नॉट टू रिमेम्बर दीज टू, only one you can learn and that should be 8085. क्योंकि जेनेरिक प्रोसेसर जो है 8085 is also the example of generic microprocessor. तो अगर आपके बोर्ड एग्जाम में जेनेरिक माइक्रोप्रोसेसर भी आता है, and if you don't know this and if you know that diagram and if you are doing writing or drawing that diagram, then also you will get full marks. तो इसीलिए बेटर वे कि इंस्टेड ऑफ लर्निंग टू यू कैन लर्न दैट 8085 वाला डायग्राम एंड इट इज वेरी इजी टू रिमेम्बर क्योंकि वी हैव डन ऑल द सब यूनिट्स. नाउ यू आर फेमिलियर विद दिस यूनिट. आपने अभी ये यूनिट देखा ही है, ये वाला जो फर्स्ट यूनिट है, दिस यूनिट, दिस इज योर इंटरप्ट कंट्रोल. तो अगर आप सारे आउटर एरियाज के पिंस देखोगे तो दीज आर ऑल 40 पिंस जिसके अंदर ये आईसी के अंदर का आर्किटेक्चरल डिजाइन है. तो इंटरप्ट कंट्रोल मीन्स यू आर हैंडलिंग ऑल हार्डवेयर इंटरप्ट एंड एक्नॉलेजमेंट्स. Okay, so in this block you can write about all or you can draw all the interrupt signal. Then you have serial IO control. तो serial IO control कौन सा सिस्टम है? SID and sort lines. ठीक है, SID is going to processor and sort is coming from processor. Then you have done this part also. This is your CPU organization, or sorry, ALU organization. We have done this diagram also, the block diagram of ALU organization. तो अगर आप देखोगे तो वही बनाया है कि we are getting the data from accumulator and temporary register and explain किया था with the help of instruction add B. So you are adding the content of accumulator with the content of register B. So that content register will transfer to temporary register and the accumulator content will remain in accumulator. Then this it will transfer to arithmetic logic unit ALU. After processing, this line again will go to this common data bus, and from this data bus again it will store in accumulator as a final result. And based on this ALU processing, your status flags will set or reset. तो ये हमने डायग्राम बना हुआ है, तो आपको इसको सिर्फ बस से कनेक्ट करना है. दिस पार्ट ऑल्सो यू हैव डन एज अ प्रोग्रामिंग मॉडल ऑफ 8085 or register organization. So we have done already BC, DE, HL, stack pointer, program counter. So W and Z, as I already told you about, these are temporary register, which is the part of your this ALU organization. Means it is not accessible by user or by programmer. Means you cannot use W and Z in your programming. This is for internal purpose or by microprocessor only. तो हमारे कौन से हैं बी सी डी ई और एच एल स्टैक पॉइंटर और प्रोग्राम काउंटर और इंक्रीमेंटर और डिक्रीमेंटर दिस इज basically used for incrementing and decrementing or helping in decrementing or incrementing the contents of register in program counter and stack pointer, right? Okay, so this is your address line 16 lines and this is your multiplex address line. This is higher order byte and this is lower order byte, this which is connected with address latch. Okay, and this one is your timing and control signal. Now these two parts we haven't done, that is instruction register and instruction decoder. अभी एक्चुअली ये वर्क कैसे करते हैं, हमारा मेन फंक्शन क्या होता है, इंस्ट्रक्शन को फेच करना, डिकोड करना और एग्जीक्यूट करना. दैट इज द मेन फंक्शन ऑफ माइक्रोप्रोसेसर. सो व्हेन वी आर फेचिंग द इंस्ट्रक्शन, फेचिंग मींस रीडिंग द इंस्ट्रक्शन फ्रॉम मेमोरी. तो वो इंस्ट्रक्शन जब हम रीड करते हैं, एक्सट्रैक्ट करते हैं मेमोरी में से, तो वेयर इट इज गोइंग, इट इज गोइंग हियर इन इंस्ट्रक्शन रजिस्टर. ठीक है, अभी हम नेक्स्ट चैप्टर जो हमारा इंस्ट्रक्शन सेट है उसमें we will study about the types of instruction. We have total 74 instruction. Out of 74 instruction, means how to classify. So we have one method to classify based on length. So we have 1 byte instruction, 2 byte instruction or 3 byte instruction. So what instruction register is storing? Instruction registers or register always store the first byte of instruction. अगर इंस्ट्रक्शन 1 बाइट की है तो पूरी इंस्ट्रक्शन इसमें आएगी, और अगर इंस्ट्रक्शन 2 बाइट की है तो उसका जो फर्स्ट बाइट है, क्योंकि हर एक इंस्ट्रक्शन के स्टार्टिंग में उसका ऑप कोड होता है, मींस उसका ऑपरेशनल कोड की which function it is going to perform. So that op code should come into this instruction register. तो इसीलिए इसको स्पेसिफाई करना बहुत जरूरी है that instruction register is a 8-bit register which is used to hold the first byte of instruction. ठीक है, that is called the opcode of instruction. So that opcode will transfer here in this instruction register. तो हमारी तीन तरह की इंस्ट्रक्शन है, 1 byte, 2 byte और 3 byte. तो आई एम नॉट गोइंग इन डिटेल, बस तीन तरह की इंस्ट्रक्शन होती है. 1 byte 1 byte की है, 2 byte it will take 2 memory location, 3 byte it will take 3 memory location. तो जो इंस्ट्रक्शन का जो स्टार्टिंग पार्ट होता है वो किसमें स्टोर होता है, फर्स्ट बाइट में. और अगर इंस्ट्रक्शन 1 बाइट की है तो उसका ऑपरेंड और ऑपकोड दोनों 1 बाइट में ही होता है. वो मैं हम देखेंगे कि कौन से इंस्ट्रक्शन 1 बाइट के हैं, कौन से 2 बाइट के हैं, कौन से 3 बाइट के. बट यू हैव टू you should know about what instruction register is storing. It is basically, it stores the first byte or the opcode of the instruction. उसके बाद वो opcode किधर जाता है, इंस्ट्रक्शन डिकोडर में और मशीन साइकिल इनकोडिंग में. ठीक है, वो इंस्ट्रक्शन डिकोडर में जाता है यहाँ पर फॉर डिकोडिंग पर्पस कि व्हाट इज द फंक्शन इज ऑफ दैट इंस्ट्रक्शन, कि इस इंस्ट्रक्शन का फंक्शन क्या है. बेस्ड ऑन दैट इट विल डिसाइड ऑल द मशीन साइकिल्स एंड एवरीथिंग विद बाय सेंडिंग दिस सिग्नल टू टाइमिंग एंड कंट्रोल. तो उसके अकॉर्डिंगली ये सारे जो स्टेटस सिग्नल्स हैं, S0, S1, IOM बार, ALE, ये सब सेट होते हैं ड्यू टू आफ्टर डिकोडिंग दैट ऑपकोड. और उसके बाद जो है डेटा जो है ALU को प्रोसेसिंग के लिए जाता है बेस्ड ऑन कितने मशीन साइकिल उस इंस्ट्रक्शन में यूज हो रहे हैं. तो फर्स्ट मशीन साइकिल में फेचिंग हुई, सेकेंड में मेमोरी रीड हुआ या IO रीड हुआ, बेस्ड ऑन इंस्ट्रक्शन. तो जो भी इंस्ट्रक्शन जा रहा है उसके बेस पे टाइमिंग एंड कंट्रोल सिग्नल विल कंट्रोल ऑल दी पार्ट्स ऑफ द माइक्रोप्रोसेसर. क्लियर. तो ये जो है 1 मार्क में आता है क्वेश्चन और टर्म आती है इंस्ट्रक्शन रजिस्टर और इंस्ट्रक्शन डिकोडर. in these two diagram, functional block diagram or generic microprocessor diagram, राइट, इन दोनों डायग्राम में से यू कैन लर्न. अगर आप जेनेरिक देखोगे तो उसमें फीचर्स कम ही हैं एज कम्पेयर टू 8085. हियर यू कैन सी यू हैव ओनली टू रजिस्टर एच एंड एम, और वहाँ पे आपके बी सी डी ई एच एस 6 रजिस्टर हैं. फिर यहाँ पे एक ही इंटरप्ट है, और वहाँ पे आपके 5 इंटरप्ट है, ट्रैप, आरएसटी 7.5, 6.5, 5.5. और इधर इसमें फ्लैग्स भी कम है, इसमें सिर्फ जीरो और कैरी फ्लैग्स हैं, और उसमें 5 फ्लैग्स होते हैं. बाकी और जो ए एल ई सिग्नल, आई ओ एम बार, वो एस नॉट एस वन, कोई भी सिग्नल नहीं है, डी ए में कोई भी नहीं है. इट इज सिंपल, इट वॉज वेरी सिंपल प्रोसेसर, बट इट वाज why it is called generic, that it was general purpose. बट माइक्रो प्रोसेसर जो 8085 है उसके और भी फीचर्स हैं, बहुत सारे फीचर्स ऐड हुए हैं. तो अगर ये वाला डायग्राम एग्जाम में आता है एंड आप 8085 वाला ड्रॉ करते हो, देन ऑल्सो यू विल गेट फुल, बिकॉज मॉडरेटर इनको कंसिडर करते हैं एंड 8085 को भी एज अ जनरल पर्पस माइक्रो प्रोसेसर. क्लियर? तो एक भी आप लर्न करेंगे, एक मतलब यही वाला 8085 वाला लर्न करेंगे तो आपको दोनों के लिए वो यूज हो जाएगा. राइट नाउ द नेक्स्ट, ये दिस these questions I have covered, that to draw the functional pin diagram. So you have to by heart the pin diagram of microprocessor. इस तरह से क्वेश्चन नहीं आता, यहाँ तक आता है ये क्वेश्चन. उसके बाद एक्सप्लेन द पर्पस ऑफ ईच पिन. So this I made question bank as an assignment that you have to write each and every pin explanation. But वैसे कैसे रहता है बोर्ड में, सिर्फ 3 पिन या 4 पिन मैक्सिमम एक्सप्लेनेशन के लिए आते हैं. Any 3 pins they can ask, or any 4 pin they can ask for explanation. 1 mark each for each pin. Okay. Next is explain multiplexed address and data bus. So that diagram you have to draw and you have to write about how ALE signal is responsible for demultiplexing of address and data bus. So when ALE signal is high during first machine cycle, it will enable the latch, and the lower order address bus will transfer in that latch. And when it goes low, and it will remain low till the end of the instruction, and that time that pins, those pins of 8085 will behave like a data bus. So this way you have to explain and draw that diagram. और ये क्वेश्चन भी बहुत बार है, what are IO mapped IO and memory mapped IO scheme. तो IO mapped IO में we have same addresses for input output devices and for memory. So who will differentiate that address is on the address buses for memory or for input output? It is differentiated by pin number 34, that is IO bar pin. IO bar pin में when that pin is low, that means you have your address on the address bus is for memory, and if it is high, that means the address on the address bus is for input output devices. But in case of memory mapped IO scheme, what happened, where we have we don't have separate addresses, we have separate addresses for IO and separate addresses for memory. तो अगर जो address IO को दिया है तो that address is not available for memory. And which one 8085 is using? 8085 using IO map IO scheme. तो ये वाला भी क्वेश्चन बहुत बार आया हुआ है. इंस्ट्रक्शन साइकिल, मशीन साइकिल एंड टी स्टेट. तो व्हाट इज इंस्ट्रक्शन साइकिल? टाइम रिक्वायर्ड टू कंप्लीट द एग्जीक्यूशन ऑफ एन इंस्ट्रक्शन. ठीक है. तो इन वन इंस्ट्रक्शन यू कैन हैव 1 to 5 मशीन साइकिल. तो मशीन साइकिल क्या, इट इज द टाइम रिक्वायर्ड टू कंप्लीट द सब ऑपरेशन ऑफ एन इंस्ट्रक्शन. तो सब ऑपरेशन मतलब कोई भी वो एक मशीन साइकिल, आईओ राइट, मेमोरी राइट, आउटपुट फेच, हॉल्ट, रीसेट, कोई भी मशीन साइकिल, दैट इज कॉल्ड सब ऑपरेशन. व्हाट इज टी स्टेट? टी स्टेट इज द टाइम पीरियड, one clock period of time that you can use to perform, matter how much sub operation you can perform in one clock period is called T state. So T state is equals to 1 clock period. और ये हमने अभी डिस्कस किया इंस्ट्रक्शन रजिस्टर, इंस्ट्रक्शन डिकोडर एंड व्हाट इज सीरियल आईओ कंट्रोल. तो इस तरह से क्वेश्चन आता है. तो इन दिस यू हैव टू एक्सप्लेन अबाउट सॉर्ट, and set pin. Okay, we have to explain about sort and set pin, right? The serial I/O control where you are transferring data serially from microprocessor to peripheral and vice versa. Instruction register always hold the first byte of the instruction, and it is 8-bit register. Instruction decoder will decode that instruction, and accordingly it will guide timing and control unit. And then label block diagram of microprocessor, so that you have to draw that big block diagram. तो कई बार functional block diagram से भी आता है, तो same you have to draw that big one diagram. और features of microprocessor, तो अभी इसमें आपके पास बहुत सारे points हैं. You can start with it is 8-bit microprocessor, it is data buses of 8-bit, address buses of 16-bit. It works on 5-volt supply. Its crystal frequency is 6 megahertz. Its clock frequency is 3 megahertz, and it has 5 hardware interrupt, 8 software interrupt. It is using IO mapped IO scheme. तो इस तरह से आप कम से कम 10 से 12 फीचर्स निकाल सकते हैं, but minimum 6 is required for 3 marks and 8 is required for 4 marks. So you can write 6 features or 8 features. So minimum 8 features तो आपको आने चाहिए, and it is very simple और easy to learn. तो ये छोटे छोटे और आगे भी हम और second chapter का भी ऐड कर सकते हो. It has 74 instruction. It works with 5 addressing mode. इस तरह से भी आप वो वाले भी फीचर्स इसमें ऐड कर सकते हैं. So this is all about first chapter. We have finished with the first chapter. तो इस ये जो है I'll revise this 5 to 10 minutes again the pins of 8085 microprocessor, and if you have any query then you can ask. So just brief me, I'm explaining again because I want that you should know all these pins thoroughly. पूरा आपको अच्छे से मालूम होना चाहिए. This subject is there in your engineering also. Third semester में ये फिर से आता है subject. So it is good for you that आप बहुत पहले इस subject को पढ़ रहे हो. चाहे quantity wise it is very less. We have only basic concept. We have many other internal circuits are there, but that you will study in your engineering grade. So first we have finished with X1 and X2. So why these pins are used? These pins are used for to generate clock signal. Here we have to connect the quartz crystal of 6 megahertz and our operating frequency of 3 megahertz. Why it is different? Because it is passing through a toggle flip-flop which divides the frequency by 2. So we are getting two phases from that toggle flip-flop. So one phase will go at pin number 37. This pin number 37 is the clock out signal that provides that clock signals to all the peripherals connected with microprocessor so that they can work with the same speed of 8085 microprocessor. After that we have finished reset in bar and reset out pin. So reset in bar and reset out pin जो है, these pins are used to reset the microprocessor as well as the peripheral. Reset in bar is basically input signal. When you press reset button, it will reset the 8085 microprocessor and it will move to its initial position. Means program counter will also move to the first address 000H. And once the processor is being reset, it should reset all the peripherals connected with microprocessor. So after receiving reset in bar signal, it will send reset out signal at this pin, and this reset out pin is connected to all the peripheral. कि अगर reset in bar आया है जिसने 8085 को reset किया है, तो reset out will reset all the peripherals connected with microprocessor. Sort and set pin, these two pins are used for serial communication. In this, sort pin is used to transfer data from microprocessor to peripheral. In this case, the data is available in the accumulator register and serially bit by bit from D7 bit of the accumulator, it will transfer to sort pin with the help of sim instruction, and from this sort pin it is available to peripheral. Same way peripheral can transfer data to SID pin, and from this SID pin again it will transfer to microprocessor, where it will go again to D7 bit of accumulator with the help of RIM instruction. So these two pins are used to transfer data serially or bit by bit to serial peripherals. Okay. Now next five pins are for hardware interrupt. These are pins. These are hardware interrupt pins. In this, peripherals can communicate with microprocessor, can take the help or can take the uh, word from microprocessor by interrupting microprocessor with the help of these five pins. So trap is a highest priority interrupt, and it is non-maskable interrupt, means you cannot enable or disable these this pin is always in enable mode, and other four are maskable interrupt which you can mask. So out of these four interrupts, RST 7.5, 6.5 and 5.5, these three interrupts are or can be enabled or disabled with the help of instruction enable interrupt, disable interrupt, or sim instruction. We can set the status of these interrupts. And but this INTR, it is also a non-maskable interrupt, but it is not enabled or disabled with the help of software. For this we have special signal generated by microprocessor, that is interrupt acknowledgement signal. In this this is the signal which is generated by 8085 microprocessor after receiving this INTR signal from that peripheral. Once it is received, it will complete its work, and if it is doing some important work, तो it will be in hold state. तो जब तक acknowledgement signal उसे नहीं भेजेगा, it will be in pending condition. Okay. Then we have a concept of priority. Trap has got highest priority and 7.5 is lower than that. So if two interrupts are simultaneously there on these pins, then who will get first? Who will be serviced by microprocessor. So first it will be serviced by who has got higher priority. So trap has got higher priority, highest priority, तो trap को service पहले मिलेगी, and that time RST 7.5 will be in pending state. Okay. So next, these are 16 address lines which is connected, which is there in 8085 microprocessor. From AD0 to AD7, these are lower order address bus which is multiplexed with data lines. Because it's the reason here that we don't have sufficient pins for, or we don't have separate or sufficient pins to accommodate data bus separately. So what they did, they multiplex that data bus with the address bus, lower order address bus, and these are exclusively available on these pin from pin number 21 to 28, higher order bus. And this multiplex, as we have already discussed, when they will be considered as address and when they will be data. So during the first machine cycle of the instruction, this ALE signal goes high, and this is called address latch enable signal. It will enable the latch and store lower order address bus address data or address to a lower order byte that will going to transfer, or that will transfer into latch. It is there in that latch, and after when it goes low, when ALE goes low, then these lines, these pins will behave like a data bus till the end of the instruction cycle. जब तक आपका इंस्ट्रक्शन पूरा एग्जीक्यूट नहीं हो जाता, तब तक ये जो लाइंस है will behave like a data bus due to this ALE signal. So ALE signal is high when during the first machine cycle, or we can say during the first clock period. जैसे ही first clock period start होता है, ALE goes high, and when it is high, when it is high, then it will enable the latch, and it will store lower order address in that latch. After that, immediately it goes slow, और ये कब तक लो रहेगा, लास्ट तक, जब तक इंस्ट्रक्शन एग्जीक्यूट नहीं होती. और जो ये लाइंस हैं, ये वाली जो लाइंस हैं, these lines now free for data. Okay. this we have done. Then we today we have started with this S0 and S1 signal. So these signals are called status signals. Status signals क्या कर बताते हैं, tell the status of microprocessor कि microprocessor is now right now doing or executing what or doing which operation. So S0 and S1 gives you four operation: halt, read, write and output fetch. But it is not giving clear picture that reading is from where and writing to here. So that is done by with the next or the third status pin, that is third IOM bar pin number 34. That will tell that reading or writing is from where. So when you combine these three status signal S0, S1 and IOM bar, you will be having 8 combinations, and these 8 combinations are called 8 machine cycles, right? So these 8 machine cycles tells the status of microprocessor. Right now microprocessor is doing or executing which machine cycle or which sub operation of the instruction. And IOM bar is also used to or it is a new pin or it is introduced in this processor only. Earlier before earlier processor this pin was not there. तो ये जो पिन है ये बताती है कौन सा stream that 8085 is using, IO mapped IO stream, where you are having all the addresses for input output as well as of memory. You can use addresses, same address for input output devices as well as for memory by using this pin. If this pin is low, means you have selected memory location, means the address on the address bus is for memory. And when this pin is high, so it means you have selected input output line, means address on the address bus is for address on the address buses for input output devices. Okay, after that we have finished with hold and HLDA signal. These two signals are specially reserved for DMA communication, that DMA controller or direct memory access device can communicate with 8085. See, this is also a device, so this can be used in interrupt system. So we can say that it is a special interrupt and for special device DMA कि वो होल्ड करके 8085 को रोक सकते हो. तो होल्ड इज जस्ट लाइक अ इंटरप्ट बट नॉट फॉर एनी अदर पेरिफेरल, इट इज फॉर डीएमए. कि डीएमए को अगर 8085 से काम है तो वो उसको कैसे रोकेगा या उससे अपना काम लेगा. तो होल्ड जो सिग्नल है दैट इज जनरेटेड बाय डीएमए सिग्नल. तो व्हेन इट इज हाई, so 8085 will complete its current machine execution machine cycle and give the acknowledgement signal that I have received. Now I will give the control of address and data bus. So after getting the control of address and data bus, DMA will transfer data directly. And after transferring of data, it will सेंड लो सिग्नल एट होल्ड पिन. और जैसे ही होल्ड पिन पे 0 होगा 8085 को पता चल जाएगा और 8085 will take the control of address and data bus back. That we have done. Then we have done the ready signal. This is ready pin. So this ready pin is used by peripherals. So it will activated or initialized by peripheral. When peripherals are ready for communication, then they will send this ready signal to 8085 microprocessor for communication. तो 8085 जो है अगर वो कुछ भी नहीं कर रहा और waiting for peripheral to communicate, then it has to go in wait state. अपने को वो wait state में ही move करता रहेगा जब तक कि ये signal high नहीं होगा. Once it is high, means peripheral is ready for communication. Next, our last two pin, read bar and write bar. These pins are showing that the data for read bar means the data which we have taken from selected input output or memory. We have read that data and it is available on data bus. और write bar क्या बताता है कि data is available on data bus. तो selected IO and memory जो है can take the data from that device. So it is now given to that device. तो these are 40 pins और VCC और VSS जो हैं these two pins to give supply. VCC to connect plus 5 volt and VSS this pin number 20 is for grounding. तो अभी I have finished again this pin diagram of 8085. So if you have